In this video, we'll create a new cam setup, import some tools to be used, and apply those tools to a pocket toolpath and a profile toolpath. So we'll start by navigating to the manufacturer space. And we'll create a new setup. So you can select the open folder. That's a quick setup. And within the setup, we have to orient our working space. So the Z-axis always needs to be in line with the up and down travel of the router head. So currently the Y is up and down, so we need to fix that. So navigate over to the orientation tab and select Z-axis plane and X-axis. We can go in from the origin point and select this current Y-axis to be our Z-axis, but it looks like the model is in the way. So I'm going to hide the bodies, and now I can select this vertical axis. Now our Z is up and down, and by default, it's in the center of the material, which in some instances is just fine. I'm going to go ahead and move our X and Y origin to this corner over here, and I can do that by selecting this box point, and it gives me a bunch of different places to locate this starting point. So I will select this upper left-hand corner, and I'm on the top of the material as well. Sometimes it's advantageous to move it down to the bottom of the material. But for now, we'll keep it at the top of the material. The next thing I need to do is double check my stock size. So by default, it's using a relative box size. So it creates a square perimeter, and it's offsetting at 0.04 inches. I'm going to increase the offset to 1/4 inch. And I'm going to leave the offset from the height 0, because we're not going to be milling off the top of the material. So now if I look at the side profile, the material and the model are exactly the same size. You can also see down here that the stock size is roughly 3.3 by 2.9 and 1 inch thick. I will select OK. So now we have a setup initiated. I'm going to need to import some tools to use. I've put in a folder here, CNC tooling. And if you double click on the wood tools, we'll be using the wood tools for foam and for wood. It'll open it up in a web browser, and we can download it and go back to Fusion, minimize this guy. We'll come up here to the Manage tab, Tool Library, and I've done this task a few times, so there's already a folder created. I'm going to go ahead and delete the folder. And to create a new one, we go to the Cloud tab here, right-click, New Library. I'll call this Wood. Come to the screen over here, and right-click on the wood again, and import tool library. It'll bring us to our desktop. Go to Downloads and Wood Tools. So now we have a few of the standard bits that we have around the shop. So 1/8 inch flat, 1/8 inch ball bit, 1/4 inch flat, 1/4 inch ball bit, and a miter fold bit that we use quite a lot of. The miter fold bit will only work on the ShopBot CNC. It's got a 1/2 inch shank, so it will not fit on the smaller DeWalt routers. We can minimize this tab now, and we'll start our pocket toolpath. Come up to 2D, select 2D pocket. And the first thing it asks for us to do is either create a tool or select a tool. So we'll go ahead and select one of these imported tools. And it looks like my wood tool tab did not take. So let me come back to manage. Right click, new library. Import. It will save it and make sure it's still there. Appears to be there. Okay. Not exactly sure why it didn't take a second ago, but it seems they've taken now. So now we'll go back to Pocket. We'll select a tool, come down on the wood, and we'll be using, for this project, a 1/4" flat bit. That's kind of the most standard kind of generic bit that we have. For the lettering, the 1/8" flat, it might come out a little bit better. There'll be a little bit less of a radius in the corners. But the 1/4" is fairly hard to break. And so it's for beginning users, it's just a little more robust. So it automatically propagates the spindle speed and cutting feed rates and ramp-in speeds. We should have no issues with these settings for now, but they're always adjustable. So you can adjust them here, or you can adjust them in the tool library if you find that a particular spindle speed or feed rate works better for you. We can come over here to geometry, and we'll select the two TU letters. We'll come to heights. For what we're doing now, the heights are not terribly critical. The main thing in here is if we want to go further than the given depth, we can drop down further by giving it a negative value. But really, we want to just match the depth that's given. We'll come over to passes, and the compensation type, climb milling and conventional milling, it's two different. If you hover over it, it shows you the two differences between what it does, and really it's something you kind of experiment with to find what works best. So if you try a climb cut and it has a rough surface finish, then try the conventional cut and see if it improves. But I kind of just leave it as the default most of the time. The stock to leave tab, if we leave this selected, it's going to leave our pocket with an additional 0.02 all the way around. And for this exercise, we really don't need that, so we'll remove that. We will use the multiple depths. So especially early on, and when you don't have the speeds dialed in, being conservative here and not trying to cut everything in one pass really helps. So the material is really soft. We probably would have no issue cutting the 0.1 depth that the letters are in one pass, but we'll just go with this default 0.04 for now. It'll allow us to correct things too if something goes wrong. These other tabs are kind of optional. You can play around with them. The feed optimization is supposed to improve the flow, so it's fine to select that. Linking parameters. This has to do with a bit how it travels into the material. And generally, I leave the linking parameters as the default unless there's an issue with it. So now I'll select OK. And it's created the blue lines is the tool path. So now we can go ahead and create the 2D contour, which is the outside perimeter cut. we will select the same tool. And you notice that now it's created a TU sample version 2 folder. So it's taking our imported tool and dropping it into a folder that's specific for this project. So we can select the same tool. And it's really nice to use the same tool with the machine setups we have because we don't have tool changers. So it kind of speeds things up. If you can find a tool that will work for all the operations, it's a lot simpler of a program process. We'll go to geometry and we'll select the bottom exterior profile. And if you notice, by default, the arrow indicates which side of the line of the profile the path will be on. So if I select the arrow, it'll put it on the inside of the path, which is not ideal. We can go ahead and take a look at the depths here. The bottom is at 0 at the moment, and we'll go ahead and leave that as well. Sometimes it's nice to cut through it a little bit, but we're going to try and avoid cutting into the spoil board for this project. We'll take a look at passes. And again, we'll use the same multiple depth passes. We're going to probably increase this to 0.1, 1/8 of an inch per cut. We will leave everything else the same. Lead in, lead outs should be fine. Okay. And you can see our tool paths have been generated. This is a good time to stop. The next thing we'll do is look at simulations and exporting the G-code.